Okay, guys, to finish up 9.7, I want to talk about multiplying matrices, okay? And the important thing with matrix multiplication is the matrices don't necessarily have to be the exact same size. However, certain dimensions of them do have to be, okay? So I'm going to run you through. They do go through kind of a step-by-step process in the book. It gets a little wordy. It's probably a good idea. Take a look at that. That may help you more, maybe less than what I'm about to do. But what I do with matrix multiplication is I take my first matrix and I notice it's a 2 by 2, okay? I take my second matrix and I notice it's a 2 by 1. What's important here is that the columns of the first matrix must have the same dimension as the row of the second matrix, okay? If these don't match, then you cannot multiply these. They do though, okay? The other important part here is that the resulting matrix will be, the resulting matrix dimensions will be the rows of the first by the columns of the second. So resulting, we will get a 2 by 1 matrix, okay? So you check the inner ones to see, okay, can I multiply them? If they match, yes. The resulting matrix will have dimensions 2 by 1 in this case, the outer ones, okay? So how do we do this? Well, what we're going to do is we're going to take the row of the first row of the first by the first column of the second, okay? And what we're going to do is we're going to multiply the first terms together and then add them to the second terms, okay? So what I'm going to get here, since I know this is going to be a 2 by 1, I'll set it up like such. So it's kind of vertical, right? Kind of like this one. And what I'm going to have is I'm going to have 1 times -1. That's the first element for this row in this column, plus 2 times 7. So just like that. So whatever that results in, that's going to be this top one, okay? For the next one, I'm going to do this row by this column, okay? So I cycle through all the rows with this column. So this is going to be 3 times -1, the first element of each, plus 4 times 7, the second element of each, okay? And if I simplify that, it looks like I have a -1 plus 14, which is 13, and I have a -3 plus, that's going to be 28. So it's going to be 25. And lo and behold, I have a 2 by 1 matrix. Okay? This is a little tricky when you're first going through it. Once again, they go a little more in detail in the book, but depending on what kind of a learner you are, it can be a little trickier. But I do encourage you to take a look at it. Now, you can do this on your calculator as well, okay? So I want you to notice that if I go to my matrices, I have the 2 by 2, and I have the 2 by 1 right here. And I can go ahead and I can literally just multiply these. I can say, okay, matrix A times matrix B. And maybe that's the easiest way to go through and do it at this point. And that's fine if you want to use your calculator and go ahead and do that, okay? Now, what if I want to do it the other way? Okay, see, we get 1325. What if I wanted to do it a different way? So what if I wanted to do -1, 7, okay, so here's a big question, times 1, 2, 3, 4. Okay. Well, here's the thing. Here I have a 2 by 1, and here I have a 2 by 2. And the big thing I want you to notice is these don't match. Don't match. So that tells us that we can't multiply these. But wait a minute, didn't we learn way back in math that it doesn't matter in which order you multiply? Well, that's with regular numbers. That's with scalars. That does not necessarily hold true for matrices. In fact, I'll try it in the same way. Instead of A times B, let me do B times A. B times A Dimension mismatch. Can't do it. Okay. Let's look at this one. Let's look at B. Okay. So it looks like I have, let's see, row by column. So that's going to be a 2 by 3. And here I have a 3 by 1. And I'm noticing they match, so I can do it. And right here, I guess the resulting, once again, is a 2 by 1. Resulting 2 by 1. Okay. So let's see. So what I'm going to do is I'm going to take the row of the first, just like before, with the first column of the second. Okay. So let's see. So I know I'm going to get a 2 by 1. I better leave myself a little room here. So I have -9 root 5, the first element of each. I have 2 root 20. Okay, that's fine. And I have -2 root 5 if I do the third element. I'm noticing that I can simplify that. I don't know why they didn't in the book. But remember, we're going to add all of those together, right? Next, I'm going to do this row by this column. I think I'm just going to have a -6 root 5. How do I know that? Well, I get 3, let's say 3 root 5. I have 3 times root 5, but then 0 and 0, okay? So if I'm looking at this, let's see, -9 root 5. If I simplify this, if I pull out a root 4, I'll get a root 5. That's going to be -9 root 5 plus 4 root 5 minus 2 root 5. If you simplify across, here it's still 3 root 5. Okay, so we're right there. And finally, let's see, I got -9 minus 2 is -11 plus 4. That's going to be a -7 root 5 for the first element. And then I have my 3 root 5. So this is the result of multiplying these guys. Okay. Last one, let's look at C. Okay. Row by column, I got 2 by 4 and I got 2 by 3. What do you notice? These don't match. So that means we cannot multiply these matrices. We can say doesn't exist. I guess that would be a good way to say it. Okay, so once again, as I said with the other section, if there's any more of these you want to see, especially with these multiplications, please let me know. You know, pick one out of the book. I don't mind doing it. That's fine. If you want to rely on your calculator for the matrix multiplication, I don't mind. If this was a linear algebra class, I would make you do it by hand, so you can do it whichever way you find easier. All right.